now. Okay, so be careful because logarithmic equations are picky. It's not nice like a exponential. Exponential, we get the number positive, negative. It's okay. In logarithm, no. So therefore, when we transform this equation to another easier equation, and we manipulate, we get a potential solution. You get the potential solution. Potential solution. Potential solution is the solution of the new equation. Okay, it's not exactly 100% equivalent to the original equation. Therefore, you need to mandatory verification the potential solution into the original equation to verify that this statement is true or false. So this is mandatory in the logarithmic equation. Okay, let's start. What should I do? Well, you condensing, you have several logarithms. In this case, you have two, no? You condensing this logarithm in only one. In this case, I'm using the property number 5. And property number 5 say that when you have logarithm, the sum, the addition to logarithm is multiplication. So you condensing, you put only one log. You put only one log of the multiplication, this expression times this expression, no? You copy x times x minus 24. Don't forget to enclose in the parenthesis or bracket because this is the argument of the logarithmic function, no? Equal 4. Okay, so the first step always is condensing. Apply the property number 1. In this case was 5. Because the subtraction here is property 6. Okay, now this is the most important moment after that. Is you convert this statement, the logarithmic statement, to exponential statement. So you put an arrow like that, and you put 2 exponential. I understand in the test, okay, the thing we are doing now is convert to exponential. Entonces, remember, convert to exponential is the base. What is the base? The base is 3. Look at that. The base is this 3. The base is 3. You put 3. It's the base. The exponent is always the answer of the logarithm. This is exponent because logarithm give me, offer me the answer. Is equal to the rest of the equation, que is x over x minus 12. Now magically, you convert one logarithmic equation in another equation que do not contain logarithm. Bueno, actually it's exponential, pero exponential is numerical, entonces 3 to the 4th power is 81. So we have 81 is equal, and why not you apply this trivial property here, is x squared minus 24x. In this moment we have in front of the quadratic equation. And the quadratic equation, well, first of all, I try to express in standard. I move 81 subtraction to the right equal to 0. Doesn't matter. Remember, you can interchange the side. The equations are completely symmetric. Now, this is a moment to using our skill solving quadratic equation. Okay, we are doing from the beginning of the semester, no? Quadratic equation, quadratic equation, quadratic equation. In this case, we can do by factorization, but it's a little bit hard. Maybe using quadratic formula. A is 1, B is negative 24, and C is negative 81. Entonces the quadratic formula is minus B, que es 24, double minus become positive, plus and minus, square roots, negative 24 squared, minus 4, multiplication by 1, multiplication by negative 81, divided by 2. 2 times 1 gets just 2. Okay, because I put in my calculator, I focus in the operation inside the radical. Look, I focus in the operation inside the radical. And negative 24 is squared. You know it's positive, right? Entonces it's 24 squared. 24 squared is 576 minus But no, minus no, double minus. We have minus become positive. Good. 81 times 4 is 324. And 324 plus 576 is 900. Okay, and square root 900 is 30. Because the square root 9 is 3, no? Square root 100 is 10. 3 times 10 is not necessarily calculated. So we have so far 24 plus or minus 30 divided by 2. Okay, you separate in two pieces. It's 24 plus 30 over 2 and 24 minus 30 over 2. This is 54 divided by 2 is 27. This is my first potential solution. Okay, need to verification into the original equation. The second one is, this is negative 6 divided by 2 is negative 3. So we have in my hand two potential solutions, and you leave it like that? No. You are in big trouble. No credit if you leave it like that. You need to verification, so the checking. Let's do in the process of the checking for x equal 27. You plug in 27 into the original equation. Okay, it's waiting for us here. It's logarithm base 3 of 27 plus logarithm base 3 of 27 minus 24 should be equal 4. I claim that because I am checking, I am verification that this is true or no. Okay, so basically it's logarithm base 3 of 27 plus logarithm base 3 of 27 minus 24, que es 3, should be 4. Entonces I will focus it in this. Remember, in this moment, I suppose that you have a skill to compute any logarithm, maybe by hand or using the calculator and conversion to a standard logarithm, and we using the calculator, no? So my goal is, what is the logarithm base 3 of 27? I need help. What is this guy? Come on, I waited for you. Answer. Logarithm base 3 of 27. I waited for you. No? Nobody know? Wow. What you are doing with the calculator? Nobody? Nobody know? Wow, why? Okay, let's do it in Professor, I don't know how to get the base. Okay. Listen to me. In our calculator, I explained the last time, no? Are you not here? In the calculator, we have a standard logarithmic. And a standard logarithm is base 10 or base e. So we have log, que the base is 10, and lm, que the base is e. And we have in the regular calculator, we have no base 3. However, I know one formula is called change of base formula. Change of base formula. Get the property number A. This formula says logarithm of the any base of the one number or expression is equal a division to think. Logarithm base B of the same number or expression divided by logarithm base B of A. Who is A? A is the all base. So the base is given. And what is B? B is the new base. Okay, the new base, you, for example, you select the logarithm base 10 that we have available in our calculator. So it's super easy. You compute like that. It's the logarithm in the calculator of 27 divided by logarithm of 3. Because 3 is the whole base, que es 3, and 27 is x. X, A is, in our specific example, A is 3, X is 27, and B is 10, because I make a decision to select that kind of logarithm, que is, by the way, it's called a common logarithm. Do you remember this or no? Sabrina, help me. Entonces, put in the calculator, please. Everyone, guys. What's the answer? The answer is 3. It's obvious que es 3. The answer is 3. So the answer of the first logarithm was 3. The answer for the second. Where's the answer for the second? Plus something. Logarithm base 3 of 3. Come on, guys. Using the same idea. Logarithm base 3 es 1. It's obvious, huh? It's obvious es 1 because there are perfect coincidence between the base number and the number inside the argument. Yeah, I know. So we studied last time one property is the property number 2. The property number 2 say the logarithm of the any base, and when the number inside the argument is exactly the same of the base is 1. And 3 plus 1 is obviously 4. This statement is super true. Therefore, that is a confirmation that 27 is solution. Good. And what about 3? Negative 3. It's obvious that it's impossible because it's a negative number, but not always happen when it's negative number, there's no solution. You need to plug it in the original. But when you plug in negative 3 in the original here, you have logarithm of negative 3. Automatically, I know that it's impossible. That this is no solution, and the only solution that we have in this equation is equal 27. Any question? Okay, guys, you have no excuse so far. I suppose you need to know that. Another possibility to compute without calculator, so we are doing in our lecture, we are doing with calculator and without calculator. But okay, the student normally prefer with calculator. But suppose let's do it by curiosity. Suppose I need to compute a logarithm base 3 of 27. And we have no calculator in this moment. You put x and you convert this statement to exponential. The base is 3. The exponent is exactly I am looking for equal 27. Yeah, I know that 27 is 3 to the cubic power. So 3 times 3 times 3. Therefore, you see that the exponent is the same. X equals 3. And the story. And logarithm base 3. In this case, elementary. No, always is elementary. No. Like sometimes you need to use. Suppose it's x. I have no idea. When you convert to exponential, the base is 3. The exponent, I have no idea. But it's equal 3. 3 is just 3 to the 1. Therefore, the exponent is x equal 1. Any question? Please. No. Sabrina saying no. Okay. Okay, we have a lot of problems today. We have 1, 2, 3, 4, 5, 6 problems. Okay, this was the first one. We are solving logarithmic equation. Suppose the second example. Example 2. We have logarithm, in this case base 2. Remember, in our calculator we have no base 2. We have a standard. but we can change, we can convert using the famous chain of base formula. Minus logarithm of base 2 of x minus 5 equal 4. Okay, we have this equation. This equation contains two logarithms, and the first step always is condensing this logarithm and only one logarithm. Okay, in this case you apply the property number 6 because of subtraction. You see, subtraction to say no, get division. Logarithm base 2 of a fraction. In the top we put the positive part, in the bottom we have the negative part. As always, I put a parenthesis to indicate that this represents the argument for the logarithmic function, no? Equal 4. Okay, so far everyone follow me? Okay, what's the next step? Conversion to exponential. The base is 2. The exponent is 4. And this is equal 3x minus 2 over x minus 5. This is a numerical value. So 2 to the 4th power, you put in the calculator, or multiplication 2 times 2 times 2 times 2, 4 times is 16. 16 is equal 33x minus 2, sorry, divided by x minus 5. That's the linear equation, but the only thing you should do is apply cross multiplication. You multiply 16 times this. Okay, and 1 times that, and 1 you know is invisible. This is 3x minus 2. We are from one easy elementary linear equation. Let's do it. Apply distributive property. 16x minus 80, no? 16 times 5, is equal 3x minus 2. In order to isolate the x, I grouping every x to the left, maybe like that. And negative 2 stay here, plus 80. We combine like 13. We combine here is 78. Divided by 13 both sides. X is equal 6. Now this is the answer? No. I need to verification in the original. See, this 6 work or doesn't work. Okay, and the original. So I need to verification. Okay, logarithmic base 2 of 3 times 6 minus 2 minus logarithm of base 2 of 6 minus 5 should be 4. I claim this because I am not sure that this statement is true. Now order of operation. 3 times 6, 18. This is 18. 18 minus 2, 16. Minus something. Logarithm base 2 of 6 minus 5 is 1. Equal 4. Okay, help me to compute this logarithm by hand or calculator, and help me to compute the green one. Look, what is the answer? Logarithm base 2 of 16. Help me. Guy, are you totally lost? You have no idea about logarithm? I hear, when I teach face to face, I hear the student in the halls say, not every semester, but frequently, I never understand logarithm. Why? No, it's easy to understand. It's just exponential. What exponent is necessary to raise the base case 2 in order to get 16? No, nobody there to answer the question. Wow. Huh? Ni Sabrina. You have no idea how we compute logarithm base 2 of 16? I'm working, okay, Sabrina. But for today, Sabrina, and the rest of the students have no calculator. Remember, Remember, I explained to you the last time, it's impossible to pass this class without scientific calculator because we are working with the special function, logarithmic and exponential, que it's impossible to compute by hand. There's no multiplication, no division, no square root. F4. The red one is 4. Okay. The red one is 4. The red one is 4. And the green one, the red one is 4. And the green one is 0. It's 0 because you have to remember this property help you to understand the property number 1 that we studied. We have 8 property. 1, 2, 3, 4, 5, 6, 7, 8. The number 1 say logarithm of the any base of 1 is always 0. Okay, so when the number inside the argument is 1, regardless what is the base, if 2, if 8, if whatever, the answer is 0. If 4 minus 0 is obviously 0, this is true statement. Now 6 work perfect. Solution of this equation is just 6. Any question? Guys, sorry, I'm confused. How do you find the logarithm base 2? Okay. Caroline, I want to explain one more time. Pay attention, please. Okay. Suppose that you are fan. You have calculator, Caroline, or no? No calculator. By hand or calculator? What means yes? Yes is not clear for me. Calculator or without calculator? Calculator, okay. Entonces, I know que logarithm base 2 of 16, this base 2 is non-standard. Standard base. Therefore, to use my calculator, in my calculator we have log only like that, and no specification of the base because default you suppose que es 10 because it's common logarithm, and you apply logarithm of 16 and logarithm of 2. Come on, put in the calculator, Caroline. Put this in your calculator. How you typing this in your calculator? Look. You press the key log automatically. When you press the key log in the display of the calculator, you see log and automatic. Aha! You see now, Caroline? Okay? This is the last time I want to explain this. Okay? I suppose you know that. Okay. Any other question? Thank you. My pleasure. Anytime. Angelica. Ruth. Okay, let's move on to the number 3 example. And number 3 example. Okay, example 3 now. Wait a second. Example 3. Example 3 is logarithm base 14 x plus 5 is equal 1 minus logarithm base 14 of x. Again, we have logarithm equation. But remember, the first step in any logarithm equation is condensing. But in this case, I cannot. Why I cannot? Because one logarithm is at the left-hand side, another logarithm is the right-hand side. But the first step in this case is move to the same side. Suppose I want stay this guy in the left, and addition because it's minus logarithm base 14 of x equal 1. Okay, now it's ready. This is a moment to condensing this logarithm only 1. And in this case, you apply the property number 5 because it's plus. And what is plus is multiplication. Multiplication what? Multiplication x times x plus 5. Everything, this expression is the expression inside the argument of the logarithmic function equal 1. Everyone follow me so far? Now conversion to exponential. Okay, good, Sabrina. So you convert to conversion to exponential statement. In exponential statement, the base is 14. The exponent is 1, okay, by the way, when the exponent is 1, it's invisible, you know, equal x parenthesis x plus 5. Okay, so we are in front, in this case, a 1 quadratic equation because you apply distributive property. We have x squared plus 5x minus 14, no? Because I move 14 to the other side. Okay, remember you can interchange because the equation is completely interchangeable, so it's symmetric. And this is my quadratic equation I need to solve it, no? In this case, I suppose it's easier by factorization because the combination is 7 and 2. So 7 times 2 is 14, 7 minus 2 is 5, plus 7 and minus 2. Then we get the solution. The first one is negative 7, and the second is positive 2. I finish. This is a potential solution, and this potential solution you need to verify one by one into the original equation. It's obvious that negative 7 doesn't work. So the negative, no 100%, depends on the equation, no? But frequently doesn't work. So you plug in negative 7 here, it's obvious negative number inside the argument of the any logarithmic function is to be undefined. The negative 7 doesn't work. But I need to prove somehow que to work. So this is u plus substitution, replace logarithm base 14 of 2 plus 5 should be equal 1 minus logarithm base 14 of 2. I need to prove using our skill that this statement is true or false, no? Well, first of all, 2 plus 5 is 7. For me, it's much better do exactly the same we are doing at the beginning. It was condensing. So it's hard to compute this. Well, we can. We put in the calculator and that's it. However, in my opinion, I prefer put in the calculator no like that, put together, okay? You put logarithm base 14 of 7. I move this to the right, to the left. Logarithm base 14 of 2 should be 1. Now, why not? We're condensing. Again, this logarithm only one use the property number 5. Because it's plus. It's plus multiplication. Multiplication of what? Multiplication 7 times 2. When you condensing in only one logarithm, we have 7 times 2 equals 14. Wow! Yeah, I know very well this property number 2 can say that when the logarithm of the any base and the number inside the argument is equal the same base, this is 1. So this statement is super true because corresponding perfectly with the property number 2. Then the solution x equal to is good solution. It's good solution, and the solution for our equation is 2. Any question? Is hard or is easy? Yeah. It's hard. Can you show me how do you do calculate again? Okay, of course. A ver, in one hypothetical example. In one hypothetical, do you have available the calculator? Sí, okay, Caroline. That one. Oh, that one. Okay, that one. Okay. Well, in this case, you suppose that you need to compute logarithm base 14 of 14. But you don't remember the property number 2. Okay, when this number is the same as 1. Okay, no problem. You put in a calculator, but in the calculator you put logarithm standard of 14, and this 14 is this 14. And in the bottom you put logarithm of 14. It's a coincidence que this 14 is this 14. Ajá, entonces dice que, bueno, este es 6, ¿no? Entonces, what? End the story. More clear now, Caroline? Tell me. Answer me. Super clear, super confused? So good. Okay, yeah. Definitely, you need to know the property. Do you remember the property? Do you want to get refresh your memory about the property? You can watch the video. Yes, please. Okay, no problem. No problem. I explain again. Don't worry. Be happy. Okay, but you have available in YouTube one video que explain. Si suppose que you have problem to be here in the video conference for the property. Okay, property 1 say logarithm of the any arbitrary base of 1 is 0. In conclusion, when you see 1 inside the argument of the logarithm, automatically is 0. Property number 2, logarithm of the any base, and when they are perfect coincident, this number and this number is 1. In this case, look at this example. 14, or whatever, logarithm of base 5 of 5 is 1. It's a property number. Property 3 and property 4 is not important. Property 5, property 6, and property 7 is super important. When you have logarithm of the any base of the sum, M and M represent number or expression. You condense it in only one logarithm, que es multiplication. M times M. What is plus? Plus is time. And minus is division. The positive is in the top and the negative is in the bottom. And the property number 7 is when you have a exponent. Suppose M to the R power, you put the exponent in the front as a factor. And the property number 8 is the chain of base formula, que es logarithm of the any base of the one specific number or expression is equal logarithm, but using another base because it's the change of base formula. Chain of base formula of x divided by logarithm. We're using the same b. Okay, it's supposed que b is the standard base, so the base that we have available in our calculator. Caroline, much better now? Can you put, I can see, okay. The picture, take a picture, take a big picture, for example 3 and the property. I don't understand why you need to take a picture, because this is available on YouTube. Okay, you receive 1 second email when the link is connected with YouTube. Are you watching this video or no? This is completely useless or is important? What is your opinion? Come on, I want to hear, coño. Oof, this is yes, okay. I want to hear. I say, what's the time? No necessarily post the video. Very useful. Okay. Very useful. Okay, useful. Let's move on to the example 4. Example 4 is a little bit complicated. You see, save me any test. Okay. Example 4 now. Example 4 is a little bit complicated. Example 4 complicated. Okay. Example 4 is Suppose 1/3 logarithm base 2 of x plus 6 equal logarithm base 8 of 3x. Okay, this is a classical example in which you have two logarithms, but this logarithm contain different base. So the example that we are doing so far, the base is the same, or 14, or 2, or 3. But in this case, we have two different bases. So this property that we study, we cannot use it. It's completely useless when you have different bases. So what is the idea then? Well, the idea is convert to the same base using the, at least you select, for example, you select base 8, convert to 2. There's one possibility, no? Or another student say, no, I don't like this. I convert 2, base 2 to 8. Okay, it's possible. And another student say, no, I don't like this. I convert both to a standard. So there are many ways to solve this problem. In my opinion, I don't know, I respect any opinion. I suppose que it's easier convert base 8 to 2. O sea, I focus in that part. I pay my attention in that part. Entonces, logarithm base 8 of the one expression que is called 3x, I want to change the base to 2. And when you have the same base, oh, everything is nice. Everything is easy. Well, everything is like a common example we were doing before. So I put a base 2 here. So I use my famous, let me copy here, my famous property A. Okay, I want to copy one more time. Look. In our specific example, A, the letter A is like a number 8. And the expression X in this problem is called 3x. I don't care. And B is the new base. I want to change case 2. Because my intention, my goal is express both logarithm using the base 2. It's 3x. The formula says it's x. No, but in our specific example, it's 3x expression. Divided by logarithm base 2 of A. Que es the old base. Do you understand very well this idea or no? Do you understand the application for the formula or no?
Yes.
Because I need help to compute this logarithm. Please, using the calculator or by hand. What is the answer? Logarithm base 2 of 8. Okay, one more time. Es 2, no, Katy, no. No, I don't think so. I don't. It's 3. Let me prove that, Caroline. Okay, look. Suppose, definitely a 4, no? Okay, some people say 2, some people say 3, some people say 4. 4, no. 2, no, it's 3. Let me prove. Look. What happened to you? You don't understand logarithm, right? You have to understand. You want to pass. Okay, look. Suppose que I'm doing A3. Okay, Katy. Okay, entonces es. Suppose you prefer calculator or by hand. Remember, we have two options, calculator or by hand.
Calculator.
Okay, calculator, good. Entonces, one more time, I apply one more time the property number A, que es change of base formula. Entonces, logaritmo base 2, que es non-standard of A, is equal log in my calculator of A divided by log of 2 in my calculator. And a specification of the base because it's supposed to get 10 because it's a standard. And you put in the calculator and the answer is 3. Please put in the calculator. Now, so far, see, I know that this number is 3. I want to copy, bring down everything. 1/3 logarithm base 2 of x plus c, I never touched that part. I only working in that part, is logarithm base 2 of 3x divided by 3. Because I discovered that this guy is 3. Okay. Easy. Look at that. Now, I cancel out that 3, no? Because it's the same stupid thing, right? Oh, so you don't understand very well why is the reason I cancel out, multiply or everything by 3. So you multiply the entire equation by 3. 3 times 131, cancel out. And 3 and 3 cancel out. And so far we have logarithm base 2 of x plus 6 equal logarithm base 2 of 3x. Everyone follow me so far? Because we almost finish. Okay, when you have two logarithmic equal each other and the base is the same, it's because the expression inside the argument is the same. And magically you convert this logarithmic equation in one linear equation. And so for x, 6 is equal to 3x minus x. 6 is equal to x divided by 2. X is 3. And this is my potential solution. I need to verification into the original equation. I'm going to verify que work or doesn't work. So the checking part is important thing in the solution of logarithmic equation. Without this, no credit or partial credit. Okay, I plug in 3 in the original equation. What is the original equation? This is the original equation. The original equation is 1/3 logarithm base 2 of 3 plus 6 should be equal logarithm base 8 of 3 times 3. Well, 1/3 logarithm base 2 of 9 is equal logarithm base 8 of 9 again, because 3 times 3 is 9, no? Entonces we can put it in a calculator if you want. But no. Okay, we are doing a more elegant way. Look, the elegant way is do exactly the same repetition, the same thing that we are doing here. Remember, 1/3 logarithm base 2 of 9 is equal. I change the base of this logarithm, like a 2. And divided by logarithm base 2 of 8, que we compute before. I don't want to do again, que 3. This is logarithm base 2 of 9 divided by 3. Y es obvio que this thing is equivalent to this. Therefore, it's true, and the solution is 3. Solution is 3. But do you understand que es mandatory the checking part? The reason is clear, because the logarithmic function is not nice like the exponential function. The logarithmic function is picky and do not accept all real numbers, accept some numbers. Okay, when you transform it, the original equation to another easier equation, not always happen, que the new equation gets easier is equivalent 100% to the original. This is not new for you. In the radical equation happens exactly the same idea. I suppose you remember in the test 1. Let's move on to example 5. Example 5 say log 3 plus x minus log x minus 3 equal log of 3. Wow, we have 3 logarithms in this equation. Well, you move everything to the one side, it's possible. Or no, you condensing, for example, the 2 logarithms on the left hand side. Wait, I see something weird in this example. And no specification of the base. What happens when there's no specification of the base? What happens when there's no specification of the base? What is the interpretation of this? Huh? Come on. Why no specification for the base? What is the interpretation of this? Hello? Are you there? Come on. Raise your hand. Caroline says, raise your hand. What is the interpretation? When the base is missing in the logarithmic function. What is the interpretation? Guys, what's going on? It's 10. Because it's 10. So you're supposed to default. So this situation happened in the test, I promise. Okay, put some equation. Okay, no specification of the base. So you need to know que default the base is 10. Okay? So this is equivalent to write 10 here. But I don't write 10. Because the algebra style is no specification when it's a standard. You need to know by memory que 10. Okay, so you apply the property number 6. Why 6? Because it's subtraction. And you're condensing this logarithm in only one. In the top you put 3 plus x. In the bottom I put x minus 3. And close everything in the parenthesis que represent the argument for the logarithm. In the right hand side we have logarithm base 3. In this case it was not necessary to condense this, because in this moment, in this crucial moment, you have two logarithmic, the base is the same, therefore the argument is the same. And disappear the log word. And it's my new equation. Okay? Well, in another example that we were doing before, we have here a number, I don't know, 40. So we cannot apply this idea, no? You need to change to exponential. But it's okay. Okay, this is 3, no? Now, why not cross multiplication? 3 plus x times 1, and 3 times this. 3 times x minus 3. Okay, now you apply this 3 with the property. Is 3x minus 9. 3 plus x is equal 3x minus 9. Okay, I try to do my best in order to solve for x. For example, this 3 stay here, plus 9, move 9 to the left, 3x stay, minus x. I move this x to the right. It's a 12, and it's a 2, divided by 2. It's 6, x is equal to 6. So always I need to check in the original equation. But in the original equation it's easy to check it because I need to prove somehow the logarithm of 3 plus 6 minus logarithm of 6 minus 3 should be equal question mark logarithm 3. This is 9. This is 3. And it's also 3. And if you apply the property number 6 here again, you condensing this in only one logarithm, okay, is 9 over 3. Okay, obviously is equal 3. Is equal this guy. So everything is okay, checking, and the solution is 6. Solution equal 6. Do you understand this or no? That was easy, eh? One more, and that's it. Question, guy, in number 5. No? No. Good. Let's do it now. One more, and this is the last one. Suppose this equation, example 6. This look like weird. This is a natural logarithm. This is natural. Natural is a standard. A natural LM is equivalent to say log when the base is e. E is a rational number that we have available in the calculator. In the calculator normally you have two keys. The key log is a common, and the other key is LM, is natural. Common natural. common natural logarithmic. And above the key we have the corresponding exponential when the base is 10 and when the base is c. And you put available this function, press first of all the function second, and the function second allowed to using this que I don't know si es en your calculator blue color or yellow color, depending the calculator you have, plus ln x plus 2. Entonces, wow, what the hell is that? Well, this is natural. Okay, but I don't care. I don't care this. I condensing this and this using the property number 5 one more time. And you condense in only one, que es natural logarithm of the multiplication x times x plus 2 inside the argument equal 4. Now ready to convert to exponential, because we have in the right hand side number, no logarithmic. Entonces the base is e. The base is e. You write the big E. Big E raised to the 4th power, que es the exponent, is equal x times x plus 2. E to the 4th power, well, it's a weird number. We can compute it with the calculator, but not now, in your moment. Now I apply distributive properties. I have x squared plus 2x minus e to the 4th power equal to 0. You have, in that moment, a quadratic equation. This quadratic equation we solve of possible solving by factorization, because I have no idea what is the e to the 4th power, but you're using quadratic formula. A is 1, B is 2, and C is negative e to the 4th power. And you apply the formula. It's minus 2 plus or minus square root 2 squared minus 4 times 1, que is a times minus e to the 4th power divided by 2 times 1, que is 2. Let me make a zoom and focus in this expression. This is 4, 2 to the 2nd power is 4, this is 4. And we have double minus, become positive. F4 e to the 4th power. Well, I apply the square roots. 4 plus 4 e to the 4. At least I can factorization 4. Factor out 4, 1 plus e to the 4th power. Yeah, I know que square root 4, you break it down like a 4, square root 4, and square root 1 plus e to the 4th power, no? Square root 4 is 2. Entonces, minus 2 plus or minus 2, square root 1 plus e to the 4th power divided by 2. We can cancel out these two. You factorization, for example, that 2 outside. Factorization in the top by 2, we have minus 1 plus or minus radical 1 plus e to the 4th power divided by 2. And these two is cancelled. The potential solution is negative 1 plus or minus square root 1 plus e to the 4th power. Entonces I separate in two pieces, the negative part and the positive part. The positive part is this. And the negative part is this. But it's obvious that the negative part doesn't work, because the negative, no? Doesn't work. Now, in order to computation this, okay, you leave it like that, or you put in a calculator to find the decimal approximation. The decimal approximation, I put in my calculator is equal approximately 6.641. Remember, in the test, normally when you get irrational numbers, and the test asks you specifically the no exact answers, approximate answer, and specification how many decimal place they want, no? 4 decimal place, 2 decimal place, etc. Any question, guys? And the next time, what is my plan? The next time we start studying the application of this. So it's a word problem somehow involving the exponential and logarithmic equation, but apply in the real life in application biology, physics, chemistry, etc. Okay, and in the test, unfortunately, we have a word problem. And finance, so money, how you invest money. Okay, guys, see you. Have a nice day.